Aloha, Richard Halverson here. This is ITS228, and it's the second video of the semester. And let me share my screen. Share. All right, so 228, and we are. Let's look at the syllabus. So we're actually still, oh no, we are in week 2, aren't we? So yeah, we're doing searching and sorting algorithms. So I wanted to mention the participation confirmation. Most of you have filled those out. You need to go to the forums and answer this question: why are you taking this class? And that way I'll look there to see if you're participating. Now, the other thing that I would do, I'm assuming that this is okay, is if you haven't done that, okay, this has to be done by by the end of this week. Like this weekend is the end, and then Monday it's over. So if you're watching this video after Monday the 24th, it's the first time you watch this video is after Monday the 24th, and it's too late, and you didn't fill out the form question. If you bought it, if you purchased the textbook, I'll count that. I think I can even go and look and see if you actually looked in the Alima. But so then what'll happen is that you would get, but if you don't do any of those things and you still want to take the class, then you send me an email, because you'll probably get an email saying, oh, you've been disenrolled, and you send me an email and say, I want to stay in the class, and then I can fill out this form to re-enroll you. And I think it's kind of to protect you, or I think it's to protect people that that don't realize they've signed up for a class, or they sign up for the wrong class, and they're attending they're just attending without paying some other class, which happened to me once with a student, and that way you can it's probably easier to get your money back. All right, so so let's go start with the textbook here. And I want to do 2 things today. I want to go through a searching and sorting algorithm, but I have a note here to look at algorithm 1.3.1. Is that a 1.3.1? No, must be algorithm. Determine. Oh, that's right. So somebody asked me to do this. No, did I say I was going to? Okay, I think maybe I just decided I was going to do. I don't know how I ended up doing it. Why I'm ending up doing this, but anyway, it's a good one. So I'm going to cover that, and maybe I'll do that a little bit later. Because I want to make sure I get through some of this other stuff first. Okay, so we're going to talk about searching and sorting algorithms, and so we're going to start out with. We're just going to talk about searching algorithms, or we talk about sorting algorithms. Oh, chapter 3. Okay, good. Well, that's good, because searching is a very simple thing to do, and there's 2 standard searching algorithms. There's the way you search if the data is not sorted, and then there's the way that you search if the data is sorted. Because when the data is sorted, you can do what's called a binary search. But if the data is not sorted, then you have to go look at every one all the way through until you either find it, or until you get all the way to the end, and then you know it's not in there. This participation activity, I guess, goes through how linear search works, and so you have to click through this. I'll click through once just so you see it. So it's looking for 14. It found 14. So it returns in index 3. So it took that many steps. And if it's looking for 11, it never finds it, so it has to go all the way to the end. All right, and then once this is done, I think I end up getting all the points. There we go. Look at that check mark up there. Okay, So that's a pretty obvious algorithm. So here, okay, so what I wanted to stress is you're going to see algorithms described like this. And this is some kind of, this is similar to C or some language like that, Java or something like that. And then, but we're going to do our programming in Python. So fortunately, with this particular textbook we have, let me go back to the library here and let me open up this section 2.3, and I'm going to open that up in a different link. Open link in new tab. And here it is. I'm going to close this now. And I'm going to pull this out. And I think I can do this on my fancy. Oh, yeah, there we go. Okay. So this is how this algorithm is expressed in this algorithmic language. And this is actually a pretty concise algorithmic language, by the way. So with these, this is like pseudocode, okay? And pseudocode doesn't have to be syntactically correct. It doesn't have to be exactly correct. It just has to be correct enough so you're expressing what you mean. And in pseudocode, we often indent. In fact, we always indent. But in every language except Python, the indenting doesn't mean anything. Okay, you don't need to indent. You can put everything way up at the end. You can put everything all in one line, and it is these curly braces that border or delineate or surround the block. Now in Python, we indent, so we don't do curly braces. We indent, and so you have to be able to convert this stuff into this stuff. And you also have to be able to write this stuff from a description. Okay, that's kind of a important thing to be able to do in being a programmer. Being a programmer where you're actually going to write some bigger programs and probably with other people too. And so that's described in here somewhere anyway. So here, this is just a one-to-one mapping, and so over here we're describing linear search where there's an array that comes in. You're looking for, or this is the maximum size of the array. In a lot of languages that matters, and this is the thing you're looking for. And so we start at the beginning, and we have a for loop starting at index 0 all the way up to the size of the array -1, and then it keeps on incrementing up to just before the number size. And in Python, it's in Python, you write the range, the limits of the range, and but this is implied. You start at that one, and this is also implied. You go all the way up to, but you're not including that one. See, that's how Python works. And then this is something that will increment I. Each time this whole thing is looked at, this thing is incremented. So anyway, so in Python, and then as soon as it's found, you return what it is. And if you get all the way to the end, that means you didn't find it, and then you return a -1 saying you didn't find it. Okay, so that's this method written in pseudocode. And then here's what the method looks like implemented in Python. So we have a definition, the name of this, it's what the name of it is. In Python, we can write it this way if we want to. This is just the convention of the book. And then we pass along the list, the ordered list, which is in regular pseudocode algorithmic language, it's called an array. And then we pass along the key, the thing we're looking for, but we don't need to pass along the size, because in Python that just comes along with this. You don't have to explicitly pass along the size. And the reason you have to do in most languages is because declare an array at the beginning of your program, you declare a size. You allocate an amount of space for that array right at that time. And so in other words, you have to say what the maximum size is going to be. And so, if you're going to do something, 10, 20, 30 elements, you might say, okay, the maximum size is 50 or the maximum size is 100. It's kind of like when you're like, well, I guess you've never had to specify the maximum size of things when you're allocating data space for them. But for Python, you don't have to. In pseudocode, they kind of make you do that. So this is a for loop which ranges from, and this is implied, 0 up to but not including number, the length of numbers, because this is the length of numbers, and if this is 1, 2, 3, 4, 5, 6, 7, 8. That's the length. The length is 8, and so this is going to be 8. And so in Python, if you say range of 8, you mean 0, 1, 2, 3, 4, 5, 6, 7. That's what you mean. And then this does the check to see if it's just like this. That's just like this. And then that's just like this. But what you see is different. Is here. Once you've specified this part, then it's a colon. It's a colon means that there's going to be something coming after it, and then the whole thing that's part of the method is indented. It's indented by 1 like that. Here, it's this curly brace and this curly brace that encloses it. Now there's going to be some curly braces on the inside, but those are all followed by ending curly braces. Here we have this if statement. And this is the beginning of what you do if the if is true. And this is the end of what you do if the if is true. Okay, here you have a for loop. This is the beginning of what you do if the for is of the for loop, and this is the end. In Python, you would put a colon there. You'd express this part differently. And you put a colon there, and all you do is you indent this part, and you don't need to put this part. When you get to this part, then you don't indent anymore. You put that here. See, that's why here, this is an indentation for the for, and this is the block of the if, and then this of course is in line with this, because this is what you do right after you're all done with the for. Yeah, see, so when you're all done with the for, then you do this. Okay, so this should just become automatic and sort of old hat right away, and because you're going to be given a lot of algorithms here. And you have to do this yourself, and the first assignment is that. But fortunately, in this book, this is a new version of this. This book is, well, anyway, it's nice because it has this is 228, right? It's nice because it has it not only has the pseudocode, but it also has these sections that actually have Python. This is a new version of this particular textbook from Zybooks that's geared towards classes where Python is the main language. Now, I'm going to teach ITS228 next in the summer, and I'm going to use a version of this book, but the language is going to be Java. Okay, so I'm going to use the same book, but it's not going to have these Python sections. So section 2.3 is going to be a Java section, and same stuff over here. And when you get to be a programmer, and you're out there in the real world, if you're a programmer for 10 years, you're going to have to learn maybe three different languages. You may end up being a Python programmer for all the 10 years, but it's likely you'll have to learn a different language, And Python is one of those languages where a lot of the newer languages that have popped up in my life in the past 5 years or so have been more like Python than they have been like pseudocode, and that's kind of a shift in programming languages these days. So Python really is a good language to be your first language, but you still got to know how to express it this way. All right, so then the main program part is we just defining an array, and and then we print it out, and then we ask the user what value to look for, and we have an input statement, so it comes out and says please, enter an integer value, and the user enters a 10, and that 10 as a string gets converted into an integer, so this is an integer value, and then that gets passed to this method here, which comes up here and finds it. It's either going to return a -1 or it's going to return the index of where that value is. And so if it comes back -1, it says, sorry, it wasn't found. And if otherwise, it's the index. So it says we found this value at this index. And this is a formatted, print where the key value is going to go in there, and the index value is going to go there. Anyway, so it looks like this. All right, so and the pseudocode is the same thing, where this specifies the array, and we have to say what the maximum size is. Yeah, we have to say what the maximum size is, and then we're going to initialize. Start out at 0, and we're going to look for 0. Oh, we initialize all these values. I'm not sure why we need to initialize them, but the first time we use them, we have to initialize them. This just prints out the array. Okay, and in pseudo language, the print statement does not automatically put a return. In Python, if you don't say anything after here, like comma and equals quote, if you don't do that, then this automatically puts a return character at the end of printing this. This one doesn't. This is what puts the return character there. So you got to do that at the end to make sure that the thing gets returned. This just, you see here, you're printing the numbers out one by one. This in Python, you can just say print that, and it prints out in a nice enough format. So you can see what they are. And then this is you have to print out the query, or this thing here, print that out separately, and it's not going to put a return, so it's sitting there at the end, and the user then it says, go get some input from the user. So it sits and waits until the user types some characters and then a return, and that gets returned, and that gets into here. That's going to be a value. Oh, get integer from user. Okay, so this automatically does the conversion. This calls the method, and it returns the key index, and then this prints out similar to this. Okay, so the reason I went through that is I just wanted to sort of, it's easy stuff, but it's not obvious that that's what you have to do. That's really what you have to do in the first assignment. That's the thinking part of the first assignment. The rest of the assignment is just going through the steps to figure out how to run programs on your little server. Let's see, it's 12:35. All right, so but anyway, that's linear search. Let's go back to this is where we were. And so this makes sure that you understand how the linear search algorithm works. If you're looking for how many will be compared to find this one, where you're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. So because it has to compare all of these until it doesn't have to compare anymore because it found it. So that's 9. How many list items will be checked if it's looking for 114? 3. Oh, I better just make sure that I'm getting the right answer here. Is it 9? Did I say? Yeah. Okay. And this is 3. Okay. How many are checked if it's not found? Well, it ends up checking them all. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It looks like. Now 11 then. Yeah. All right. So an algorithm's runtime is the time that the algorithm takes to execute. And so if you can think of each comparison taking a microsecond, a linear search algorithm's runtime is up to 1 second if there's like, you know, if there's like a million elements, because a microsecond, there's a million microseconds in a second. Micro means 1 millionth. So 1 million microseconds equals a second. So if each comparison takes 1 microsecond, then if you've got an array that's got a million unordered elements and you're looking for one of them in there, it could take up to a whole second to tell you that it's not in there. Okay. So that's, and we're going to get into, you know, how to express different algorithms have different behavior. With a linear search, if you double the size of if you double the number of elements, like if you have 1 million elements and it's not in there, it's going to take 1 second. If you double it to 2 million elements, it's 2 seconds. If you double that to 4 million, it's going to take 4 seconds, and so on. So so the whole science, or skill, I should say, it's just really a skill, because you just learn how to do it and then you can do it. It's like being able to add and subtract is a skill. The skill of figuring out what the quote computational complexity is of an algorithm, that's what it has to do with. When you double the size of the data that's going in there, what's the expression, or what's the equation for figuring out how much more time it's going to take? And for a linear, it just doubles it. It's just time, or if it's doubled, then it's times 2. With the binary search, it's not. It's the log to the base 2. It adds log to the base 2, and we'll see what that means in a second. So anyway, make sure you understand this. Okay, for the binary search, the only thing is that the data's got to be sorted first. So it only works on sorted data. And so the idea is, so a linear search has to search through all the items starting at the beginning, one at a time down the line. And but linear search requires searching all those elements. For example, searching for a contact in a smartphone one by one from a list first to last can be time consuming because a contact list is sorted. Okay, a faster search known as a binary search checks the middle one first. Okay, so the way binary search works is if it's sorted. Okay, so let's say you're in here and you're looking for Puja. Let's say searching for Puja using the binary search starts by checking the middle contact. Okay, so what it does is, okay, let's just go through this and you can see it. You should step through this. Okay, so a contact list stores contacts sorted by name, and it's searching for it's searching for Puja, somebody named Puja. And so the way but it's sorted. So the first thing it'll do, it knows the middle, it's sorted, right? So it knows how to get to the middle because it's just the size of it divided by 2, that's the index. So it knows in one step how to get to exactly the middle of the list. And it does this, and look, it finds that the guy in the very middle of the list is Muhammad. And so then it knows, well, Puja comes after Muhammad. So right away, you've eliminated the left half of the list. So in one search, you've eliminated half. And then now it's all in this half. Well, you do the same thing. You find the halfway point, and Puja is either going to be, that particular index, or it's going to be lower or higher. And if it's lower, you've eliminated the top quarter. If it's higher, you've eliminated from the halfway point to the 3/4 point. So each time you do a search, or each time you look at the middle index, you are eliminating, you're either bingo finding it, or you're eliminating half of the set that you're looking at. So if you start out with 1,000, the first thing you look at, it's going to eliminate 500. And the next time you look, it's going to eliminate 250. And now we're down to 250. And then it's going to be 125, and it's going to be 62, and it's going to be 32, and it's whatever, it's 31, 16, 8, 4. And so how long does it take to get all the way down to where you're either not going to find it or you have found it? Well, it's log to the base 2. That's what the log to the base 2 function is. Okay, log to the base 2 of 1,000 is about 10, so on. So if you have 1,000 elements in 10 examinations, you will learn. And that's the worst case, because oftentimes you learn it sooner. All right, so we look at Muhammad. It's not Muhammad, but it's going to be in the top half. So we've eliminated Muhammad in the right half. So then now we look for and we find Sherrod, and so it's not going to be, it's not the top half because Pooja is less than Sherrod. And we go in here and that splits up, and look, bingo, we've hit Nigel and Robert. The middle one was Pooja, and we found him. Okay, and I got my check mark. Okay, so you can see that binary search is more efficient. And you can also see where, since each time you double the size of the sorted array that you're searching, if you double it, well, you're only adding one more step, because in one step you eliminate half. One more step, you eliminate half. And you keep on eliminating half, and pretty soon you're down to either you found it or it's not in there. And so whereas with linear search, if you double it, you double the size of the array, you're doubling the amount of time that it's going to take to, worst case, to find an element. With a binary search on a sorted list, if you double the size of the sorted list or the sorted array, it only adds one more step to a binary search. So anyway, let's make sure that these are all sorted, and binary search algorithm. Here, this is another participation activity where you can see how it let's see what it does here real quick. Okay, oh yeah, so it keeps track of the low and the high, and it's going to look for 16, I guess. So then it takes the middle element, and what is the middle element? This is the middle element, 14. So and it looks at 14. It says that 16 is not equal to 14. 16 is greater than 14. So now it's going to move. Okay, so this is the low, this is the mid, and this is the high, and what we're looking for is higher than the mid. The one we're looking for is bigger than the mid. So we're going to take the low and move the low right up to here. Okay, the low is going to be right there, because we know it's not the mid or anything below the mid. We know that it's at least index number 4 up to index number 7. So that's what this next step does. So it moves low over there, and then it finds a new mid, which is in between there. And look, it happens to be low, happens to be sitting on the value that we're looking for, but it doesn't matter because we're going to check the mid value first, and it's less than the mid value. And what happens is eventually high and low, actually what happens is the last step was moving high, and you end up moving high below mid, and then you end up high is lower than low. High is lower than low, and then you know you're done. So anyway, that's how the algorithm actually works. But there you saw that how it works. And here is the binary search algorithm. And here we're actually looping through, and we find the midpoint, and we check the midpoint with what we're looking for. And if the midpoint is less than what we're looking for, then we know that we want to put the low point one notch above the midpoint. if the number that we're looking for is greater than the midpoint, then we're going to want to put the high to 1 less than what the mid was, and do it again. And so high and low keep getting closer and closer together, and eventually eventually it'll reach a point where this is not true. It'll eventually reach a point where low is greater than high, and then you know you've gone too far. Then if you haven't found it, then your highs and low, your high and low pointers have crossed, and it's not there, and that's when it's going to return a -1. So here if it's not true that the midpoint is lower than the key, and it's not true that the midpoint is higher than the key, then the midpoint must be, you know, the key value. So then it just returns that index. All right, so that's how binary search works, the iterative kind of binary search. And this is how you express this. It's log to the base 2 of n plus 1. This is we'll get more into what this actually means, what this things mean, and so on in the future. But anyway, this is how you express binary search efficiency. Log 2 of n, or log of n, basically. All right, so this makes sure you understand, if suppose a sorted list of 1024 elements is searched with a binary search, how many distinct list elements are compared against a search key that is less than all the elements in the list. So suppose is searched with a linear search. How many distinct list elements are compared? Oh, that's not in list, I guess not. So it would be, I used 1024, that was the answer before. Okay, and this one is going to be log to the base 2 of 1024 plus 1. Yes, so it's going to be log to the base 2 of 1024 is 10. 2 to the 10th power is 1024. 2 to the 9th power is 512. 2 to the 11th power is 2048. So I memorize those up. Doubling starting from 2 up to a ways is not a bad thing to remember. Especially knowing that, well, anyway, so it should be 11, I'm thinking. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's 10, but that's not this. Log to the base, log 32. 2 to the 5th power is 32. So it's 5 plus 1 is 6. 2 to the 10th power is 1024. 1024 plus 10 plus 1 is 11. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, anyway. I think I should give them feedback on that, but I'll do that. All right. So here is yeah, so here, so it looks like this challenge activity, let's say the first one you're looking for is web. What is the first name? What is the first? Let me start it up and see. What is the first? Oh, last name. These are last names. 0, 1, 2, 3, 4. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 5. 0, 1, 2, 3, 4. I think it's, is this the 1, 2, 3, 4, 5? Okay, I think it's Luna. Zero plus 9 divided by 2 is 4. So 0, 1, 2, 3, 4. I'm going to say Luna. Oh, what's the second name? And once it's Luna, then the next one will be Hall. Yes. Oh, wait, because we're searching. What are we searching for? Oh, we're searching for Page, so it's not Hall. It's halfway between. Okay, that's halfway. We go Ross. Ross is the next one. Okay, see, so we're searching for page, and the first one we get to is okay. So this is index 0. This is index 9. So 9 plus 0 is 9. Divided by 2 is 4.5. We take the integer part, so that's index 4. 0, 1, 2, 3, 4. That's Luna. This is how I'm computing this. Is it right? These are indexes. They're all indexes. Yes. So high plus low divided by 2, and it's the integer part of that. Yeah, you just have to know that this is integer. These are integers. So yes. So my calculation is correct. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 plus 0 is 9. Divided by 2 is 4. Okay, so 4. And the fourth one is 0, 1, 2, 3, 4. 0, 1, 2, 3, 4 is Luna. And then its page is higher than Luna. So low gets moved from here up to here. So now this is low and this is high. And the middle of that is going to be raw. Okay, so anyway, is that right? Yeah, that's correct. Okay, so I think you can probably do the rest of those. Time is it? 12:53. So these are the Python versions, and what you need to do for your assignment, might as well talk about your assignment, I guess, is you have to see. I should probably do this assignment here. Okay, so you have to log into your server. Your server is your username, your regular email username, followed by ITS228.com, and your cPanel login is that where it's the first 5 letters of your username, followed by 228, which are the 3, the digits of this course. And I do this because I'm now having students, more than one student, a student having more than one account, so I have to distinguish it in some way. And then your password is going to be, this is your last name, the first initial of your last name, followed by the first initial of your first name. So my name is Richard Halverson, so it's HR, and the H is capitalized. The H is capital, and then this is my 8-digit, my 8-digit UH ID. It's not really, but if that's it, then that's that, and then followed by % hashtag exclamation point. Okay, so in other words, richardh.its228.com. Okay, so this is my website, but we're not going to use it as a website. We're going to go in and log into the server part, cPanel. We'll be using it as a website later on semester, but right now we're just using the server part. So I log in and I type in RICHA228, and then my password is HR % hashtag exclamation point, and save it. And I'm going to go to File Manager, and and then I'm going to create a folder called Assignments. Okay, I'm going to do all this now. I'm going to change the name. I've already done the assignment, so I'm just going to change the name of this to something else. So I can start over again. So I don't have this. Okay, so we're going to be using the file manager and the terminal. So I've shown you the file manager. You just come to cPanel here, and you click on File Manager under Files, and this thing pops up. Okay, and then we're also going to use terminal. It's under advanced. Now, terminal, I'm going to right click and then open it up in a new tab, because if you click on that, cPanel goes away. Anyway, so here's the terminal, and it looks like this. Okay. Now, the first time you log into terminal, it's going to warn you, say this, you know, be careful, you know, this is, you know, you can damage your server or whatever, but just click OK. And then it comes to this, and this is your prompt. This is the terminal prompt. And we're going to be using Python 3. Okay. Python 3.6.8. Okay. I'm going to exit. And so those are the two things that we're doing. Now, the first thing I want you to do is to implement this algorithm. So to do that, create a directory called assignments. We are in File Manager. I'm going to create a new folder. Okay, I just logged right into File Manager. I'm at my home directory. You can see up there. I'm going to create a new folder called Assignments, ASSIGNMENTS. And here is my new folder called Assignments. I'm going to double click on it to go into it. It's empty. And then I'm going to do some stuff here. I'm going to put this, over here. And I'm going to take this out. Okay, so it's empty. I want to be watching this. Okay. Okay, and then inside assignments, create a directory named 1. Okay, so I'm going to create a new directory in here called a new folder called 1, because it's assignment 1. See that? Okay. And then I'm going to go into 1. And by the way, I'm going to pop open assignments here, and we see 1 is there. I'm inside 1. And then I'm going to create a new file called binarysearch1.py. So I'm going to create a new file down here called binary_search1.py. And I'm going to say create new file. And here it is right there. And I'm going to edit binarysearch1.py and copy the code from figure 2.3.2, and then I'm going to save it. So I'm going to click on here, and I'm going to click up here on sort of an edit thing. Click on it. Oh, there we go. Edit. And I go to 2.3.2. 2.3.2 binary. This one was supposed to get running. Copy this. Copy. And go over here and paste it in here. Paste. And save it. Save my changes. Okay, there it is. Now, to verify my program is in the correct place, return to my home directory and type return to my home directory. Okay, this is a bug in the assignment. It should say in your terminal program. Okay, so you're supposed to do this in your terminal program. I hope people understand that. You should be here, and you should type cat assignments /1/binary_search1.py. And it should display out. There it is. See it displayed out. And then this is my prompt again. So that's all I wanted to do. We can confirm that that is there. This is terrible that I don't. Sorry, I'm trying to fix it. So, so anyway, that works. And then you can execute the program by typing Python 3 in that program. And so let's do that. Python 3 space assignments /1 / binary search 1.py. And we see it executes. First it displays out the numbers. This is just like when it executes here. First it displays out the numbers, and then you say enter a value, and we can enter a value, say 10. And it says, it gives the answer. We can run it again, and we can ask for some number that's not there, and it says it's not found. All right, so that confirms that it works, and then you can go to okay, I'm just going to fix this here. Open the terminal app, and in your home directory, type open the terminal app, and in your home directory type that. All right, so that works, and then you can go to the grading assistant. Go to the grading assistant and type in your this works. Type in your username and your password, and then type this. Click on submit, and this actually kind of logs into your account and actually executes it and gets feedback. And let's see, takes a little while to run. So anyway, while that's running, the reason it takes so long is because it actually logs into your account and does a few things, lists it out, as you can see, executes it again, and then when it's all done, it logs out and gets rid of anything that it left. Sometimes it might upload some files into your account and so on. But anyway, so this is the output. I got all the points. And so what this does is, first of all, it CDs into assignments, CDs into the directory, makes sure you have all that there. What this does is, this is something that if you copy, when you are in the file manager and you copy and paste something in there, what happens is it pastes in carriage return characters after each line. And that messes up the Python interpreter. So to do that, you have to get rid of those carriage return characters at the end of each line. And there's a command to do that. And so I go ahead and execute that command for you to make sure, in case you have any of those, and I get rid of them, and that's fine. And then I actually do this NL-B. You can execute these commands also from your terminal. And this lists all your programs, but it gives you line numbers also. And so it helps you to see what actually is executing, helps me to see when I run this. If you contact me and say something's not right, then I just can go to my control panel and look at this and tell you what's wrong. And then it first it executes the program, and you see this is the output from the program up to there. and then it inputs this and does that and checks to see if it found it. It did anyway. And then so here it adds up your points and you got all the points. Okay, so that's the grader thing, and so you want to do that. And so now for the second one. Second one's a little bit more difficult. You can close this. You have to, in this part, you'll create a copy of this called that, and then you're going to add the recursive binary search algorithm to it. And then you're also going to modify it so it asks the user for a list of numbers. And then it converts that to the list and then executes it. So so from the file manager, go inside here and make a copy of this. Okay, so I'm inside here and I'm just going to make a copy of this. So I click on it and do a right click and I can say copy. It asks me, I have to type in /binary_search2.py. And there it is. And so I'm going to open that up. Edit. And here it is. Okay, so the first thing I'm going to do is edit this and do the following. Enclose the main program in this. And the reason I do that is because I want to be able to take your entire program here. I'm going to take your entire program. This is to grade your program. To grade your program, I'm going to take your program and I'm going to import it as a module into another program that I'm going to send up to your account. I'm going to run this other program, and it's going to import your program as a module. And I want to be able to execute this separately. And I also want to be able to execute this recursive binary search thing separately. And to do that, when I import your program into my program as a module, I don't want this to execute. I don't want that to execute. So the way I make it not execute is I enclose it in an if block, where this is the main if statement. So I'm gonna just do this, paste that there, and make this the if block. And to make this the if block in Python, I just tab it in one, and then now this will only execute if it's the main program. So I can still execute this as the main program, it'll work fine. But if this code here is imported into another program as a module, to be able to use the methods in here, then this will not execute. All right, so that's what that's for. And then I'm supposed to implement the recursive binary search described in 2.9.2 as a Python method that looks like that. Okay, so I'm gonna go to 2.9.2. And I'm going to implement this. This is a recursive binary search program, which I didn't cover yet, but I'll cover that next time. But I want to get you started on this assignment. And basically, what this does is this calls itself. And I'm going to I will get more into that next time. But basically, what we're going to do is we're going to copy this. No, I'll do this first. First, take this, copy, and go over here and paste it in. Don't paste the period in. And then this is going to be this binary search program. I'm just going to put a pass in here right now. And then I also want to copy in this. And this thing is going to call this binary search program. See right here, it calls it. And that's because in the normal binary search program up here, you only pass it the array or the list and the item you're looking for. But in this binary search algorithm, you're passing it both the array and then you're passing it the low value and the high value because it's looking for something that's in part of the array. And then here's the key value. We have to make this be able to interface to this program down here. So I've created this method here, which just takes in numbers and key, just like this up here, and then makes the first initial call to this method. And the low number is going to be 0, and the high number is going to be the length of this list minus 1. All right, so so now, oh, and then we want to change. We want to test this. To test it, we want to change. Instead of calling this one, we want to call our recursive binary search. And then it should operate the same way. So this is the non-recursive binary search, and we need to implement the recursive binary search. Okay, so let's go over here and let's grab this. Let's grab this, copy it, and I'm just gonna paste it right here. Okay, see, so this is pseudocode, and I have to convert this. I have to convert this pseudocode into Python. Okay, so this is fine. I've gotten rid of that, and we're indenting. That's good. Let's see. I'm just gonna. So I got rid of the left curly. I'll get rid of the right curly. And then let me just get this up here. I'm gonna move all these back by 1, so there's no. And so there's an if statement, and this is fine. I'm going to put a colon there, and this should be the indented version of that. This is going to be if the high value is lower than the low value, then we've crossed. And it's not there. So this is why we return a -1 right there, because we've actually high is crossed low, and we didn't find it, and so we're not going to find it now, and so we return 0. Otherwise, we compute the middle, and this looks like this might work, although it should be an integer divide. And then we're going to have this if statement here. And that looks like that syntax is okay. This is going to be a colon there. And this is the return. That looks good. This is just this. And there's no ending curly because it's indented. That takes care of that. Oh, then there is this else for this one. Else, and in Python, it's elif. It's elif. And we don't have curly braces. We have colons and indents. So this is the indented part, and we don't have this because it's indented. And this looks like this is pretty good looking Python. Oh, we're going to return. Okay, yes. So this is going to be indented because it's part of the binary search program. So so if this thing comes in and low has crossed high, then we return -1, didn't find it. Otherwise, we compute a new midpoint, and we look at the midpoint and we see if it's less than the key. If the midpoint is less than the key, then we do a binary search on the lower half. See this wait, if the mid is less than the key. I wonder if these are reversed. the mid is less than the key, then we search. Yes. Oh yeah. Oh, okay. Right. If the mid is less than the key, then the key we're looking for is in the upper half, and this searches the upper half. This sets the low to the mid plus one, and this is the high again. So okay. So this is how that works. This might be all we need. Then we need to. I've got a couple more. It's past the time, but let me finish this up for you. You need to convert this here. So instead of doing that, you're reading in numbers. Let's make this a comment. And let's read in the numbers. Numbers. Okay, I'm going to say number string equals input. I'm just going to leave it at that. I'm not going to ask. It doesn't. Do I? Enter string of numbers. And then I'm going to convert that to a list of integers. Convert it to a list of integers called numbers. Numbers equals, I'm gonna do a what's that called? I gotta go back here. This is the wrong textbook, isn't it? All right, well, I'm gonna do it. How do I, okay, it's something like this. I'm gonna try to do this from memory. Is a list of integer of x for I can't remember how to do this. Okay, I'm just gonna do it manually. Nums equals numbers string split. Okay, so that splits them into an array of numbers, and then I'm going to do numbers equals nothing, and for n in nums, numbers append int n. Okay, that's going to create my numbers list. All right. So I'm going to try this, save it, and I'm going to go to the terminal, and I'm going to try to run it. And it's going to be not binary search 1, but binary search 2. And the first thing it does is ask me a string of numbers. I'm going to say 2, 4, 7. It's got to be sorted, remember, because it's binary search. 10, 11, whatever, 32, 45, whatever. Okay, that's a list of numbers. And it reads it nicely, displays it out again. 2, 4, 7, 10, 11. Yeah, that's the number. That's what I typed in. It's not what this is up here. It's what I typed in. Now I'm going to look for 11. And it was found index 4. And so I'm going to run this again and try to type in the same thing. Whatever. Enter a value that's not in there. Ooh, it's not in order. That's not going to work. It's not going to work. So I'm going to trick it. What's the middle one? 1, 2, 3, 4, 5, 6, 7, 8. So it'd be 4. I'm going to say 8. I'm going to try this again because I want to make sure it works. 3, 4, 5, 6, 7, 9, 10, 12. Okay, those are all in order. And now I'm going to find one that's not in there. It's 11. Yeah, okay. And then we can test it by doing this. And regardless of whether this works, I'll end the session and we'll continue next time. I should spend more time explaining binary search to you, a recursive binary search, because we are going to have to understand recursive algorithms well enough to be able to write some simple recursive algorithms. Recursive algorithms really come in handy when we're searching binary trees. They really come in handy then. All right, so this is what the output looks like. And so this is what my program looks like. And I did get all the points. It actually uploads a program that tests your program as a module by, by testing. It actually tests like this directly. And it actually tests this directly. So anyway, so I've covered a lot of chapter 2, not all of it, but I did go over the first assignment. Should be able to help. You should be able to do it all now. In the future, I'm not going to do the entire assignment for you. I'm just going to do enough of it so you can get started in case there's anything new. But this assignment really is about learning how to run programs on your server so they can be graded, and also converting an algorithm written in pseudocode, converting that directly into Python. And it was kind of good in this case because we converted this algorithm without even really understanding the algorithm. Converting is a mechanical process, and as long as you keep that in mind, then you don't get bogged down in actually what it is you're converting. So anyway, do you have any questions?
Good, thank you.
All right, so I will see you next time. Thanks for watching.